Good morning, students. As yesterday, we were discussing about numericals regarding dimensional analysis, and in that context, we had discussed the part 19 of the video, but due to certain technical problems, that video consists of only certain parts of the numerical portion, and the rest of part we are going to discuss in this video. The half part of this question is covered in that video, so we had started discussing in this video from the very beginning of this question, and the question was, if velocity, force and time are taken to be fundamental quantities. Velocity, force and time, velocity, force and time are the fundamental quantities, then find the dimensional formula for mass and energy. Then we have to find the dimensional formula for mass and energy. So Q is the function of velocity, force and time. Now first of all, we will find the dimension for Q is equal to V x, F, y and T, Z. Now writing the dimensional formula Q, K, LT minus 1 power x, M, LT minus 2 power y and T power Z. Now solving it dimensionally, we will get dimensional formula for Q is equal to K and M power y, L x plus y, T minus x minus 2y plus z. This is the dimensional formula for Q which we have obtained. Let us suppose this is equation 2. Now the question is asking, find the dimensional formula for mass and energy. Find the dimensional formula for mass and energy. So first of all, in section A, we will consider Q as mass. We will consider Q as mass. So since we are considering Q as mass, so it is M K M Y L x plus y T minus x minus 2y plus z. Now look at here, the power for y is 1. So by principle of homogeneity, by the principle of homogeneity, y is equal to 1, x plus y is equal to 0, and minus x minus 2y plus z is equal to 0. Putting the values of y here, you will get x is equal to minus 1, y is equal to 1 and z is equal to, solve it for z, you will get z is equal to 1 also. Now putting these values in equation 1, substituting this in 1, then you will get Q is equal to K, since K is dependent on velocity power minus 1, force power 1 and time power 1, and you will get the formula Q is equal to K Ft upon V. Q is equal to K Ft upon V. This is the case when Q is considered as mass. Now we are considering Q as energy. we are considering Q as energy. If we are considering Q as energy, then the dimensional formula for Q is ml square t minus 2, which is equal to K m y l x plus y t minus x minus 2y plus z. Now equating it dimensionally, then y is equal to 1, x plus y is equal to 2. The dimensions, by the principle of homogeneity, the dimensions will be same. So y is equal to 1, x plus y is equal to 2, and minus x minus 2y plus z is equal to minus 2. Now putting these values, we will get, on solving it, we will get the value x is equal to 1, y is equal to 1, and z is equal to 1. On solving by solving this for x and y and z, we will get x is equal to 1, y is equal to 1, and z is equal to 1. So for energy, the formula for Q is equal to K V F and T, because in equation 1 we had discussed Q is equal to K V X F Y and T Z. Now limitations of theory of dimension. Limitations for theory of dimensions. Limitations for theory of dimensions. Limitations for theory of dimensions. What are the limitations for theory of dimension? The first limitation for theory of dimension is that the dimensions are given, physical quantity may not be unique. If dimensions are given, physical quantities may not be unique. Physical quantities may not be unique. Suppose, for example, it is given that if you have given that the formula for dimension for ml square t minus 2, it will represent, first one student will tell it is the dimensional formula for work, second student will tell it is dimensional formula for energy, and the third students will tell it is the formula for torque. All the students are correct. So there is no any unique dimensional formula for a given physical quantity. So by seeing only the dimensional formula, you can't guess the physical quantity. The second limitation is dimensional formula for constants and ratios cannot be determined. Dimensional formula for constants and ratios cannot be determined. Example, that is dimensional formula for constant like pi, 1/2 refractive index. Refractive index. It is the dimensional formula for these quantities cannot be derived by the help of dimension. The third limitation is in case of third limitation, we cannot able to derive by the method of dimension. By the method of dimension, it is not able to derive the dimensional formula for the physical quantities which have dependency on more than 3 physical quantities. If a physical quantity depends on more than 3 physical quantities. If a physical quantity depends on more than 3 physical quantities, then their dimensional formula cannot be derived, because in this case the dependency of physical quantity, suppose example I am telling, t is equal to 2 pi under root I upon mgl, 2 pi I upon mgl. Here time period is depending on moment of inertia, mass, acceleration due to gravity and length. And so time period is depending on 4 physical quantities. But we have only 3 equations. Number of unknowns are greater than number of equations. Number of unknowns greater than number of equation. So we can't derive the dimensional formula by the help of dimensional analysis in this case. Fourth one is the method of dimension cannot be used to derive relations other than the it cannot be used to derive the relations other than the product of powers. Product of powers means if the dimensional formula is depending on 3 physical quantities which are in the form of products, then suppose it is given that if force is directly proportional to coefficient of viscosity and radius r and velocity v, then by the help of dimension you can find the relationship between them. You can find easily because they are in the form of products. You can write in the form of products, and by giving it the power a, b, c, you can calculate it, then derive. But suppose there is the case when the dimension formula is like s is equal to ut plus half at square, or b square minus u square is equal to 2as, or y is equal to a sine omega t. In this case, by the help of dimension, you cannot derive the relation among the physical quantities. And the last limitation is even if physical quantity depends on three physical quantities, even if a physical quantity depends on three physical quantity, out of which two have same dimension, out of which two have same dimension. The formula cannot be derived by the help of dimensions. The formula cannot be derived by the help of dimensions, by the theory of dimensions. Example: frequency of tuning fork. Frequency of tuning fork, that is F. Frequency of tuning fork, F is equal to D upon L square into dV. Now here D and L have same dimensions, so we cannot derive the formula by the help of dimension. This formula by the help of dimension, because two physical quantities have same dimension. So if any physical quantity depends on three physical quantities, out of which two have the same dimension, that formula cannot be derived by the help of dimension, but their dimensional consistency can be checked. Dimensional consistency in each case we can check by the help of dimension, but we can't derive the dimensional formula. So this is all about the dimensional analysis, students. We had solved the numericals, we have discussed each and everything regarding the dimensional analysis. So from the next video we will study error analysis. So thank you, students, have a nice day.